Poštovane koleginice i kolege, uvaženi gosti, dragi prijatelji. Data mi je posebna privilegija i čast da danas vodim ceremoniju otvaranja jubilarnog 55. kongresa o klimatizaciji, grejanju i hlađenju. Sa velikim zadovoljstvom konstatujem da je sa nama, kao i svih ranijih godina, profesor Branislav Todorović, predsjednik Društva za KGH, i jedan od utemeljivača ovog kongresa. Molim profesora Todorovića da nam se obrati i da otvori 55. kongres o KGH. Profesore, izvolite.
Ja ću da ostanem da sedim, ne mogu da stojim, da vam ne padnem ovde, da izgubim ravnotežu. Počelo je to kad sam bio mlad asistent na fakultetu mašinskom u Beogradu. Sorry, I'll speak on Serbian, and you will understand. You were so many times here, so maybe you learned a little bit Serbian language. I čudnom okolnošću sam uopšte čuo da postoji Savez inženjera i mene je profesor pokojni Đaković uputio kod tadašnjeg sekretara da se javim i da dobijem neko zaduženje. I tako je počelo. Počelo je i skoro da se završilo, ali još nije. I to mi je otvorilo velike vidike. Počeli smo da radimo, da organizujemo Savez inženjera i to je u stvari bila dopuna redovnoj nastavi Mašinskog fakulteta. Sad se počelo da se priča da bi trebalo možda da se organizuje neke poslediplomske studije sa stranim fakultetima u Beogradu. Ja sam protiv toga. Mislim da smo mi toliko prošli sveta, da smo internacionalci i da od nas još uvek može da se nauči, ne samo na fakultetu, nego evo u kombinaciji sa Savezom inženjera. Tako je to počelo. I evo sad smo izbrojali da je ovo 55. ili 56. kongres, 55. kongres. Ne mogu da verujem da sam ja bio u organizacijama skoro svih 55 kongresa i sad se ja iznenadim kako sam to voleo i kako sam to sarađivao sa kolegama starijim koji su me u to sve uveli. U to vreme predsjednik Saveza inženjera je bio profesor Đaković i on me je uveo i tako je to počelo. Pravo da vam kažem, ne verujem ni sam da je meni ovo 55. kongres i još neki koji još nismo onda u ono vreme računali. Počelo je to na jugoslovenskom nivou, a sad se sve to okrenulo, ali ostali su ljudi isti, verni i kao prijatelji, i kao drugari, i kao naučnici. I živi bi bili. Ja se nadam da je moguće da ću da budem još jedan puta na kongresu, ali to je samo puka nada, Ja vam želim, dok sam tu, i prijatan boravak kod nas u Beogradu i dalju saradnju koju smo počeli i koju održavamo. Živi bili i sve najbolje.
Hvala profesoru Todoroviću i 55. kongres je u ovom momentu otvoren. Hvala profesoru Todoroviću još jednom. Koristim ovu priliku da sa posebnim zadovoljstvom svi zajedno pozdravimo naše drage kolege koji su od prvog dana zajedno sa nama. Dozvolite. Profesorka Marija Todorović, jedan aplauz, pozdravimo je. Hvala lepo.
Izvinite, nisam rekao, dobro sam se oženio.
Da, to je jedan od glavnih uslova. Profesor Nenad Đajić, pozdravimo ga. I kolega, mašinski inženjer Ištvan Vanjur. Pozdravimo ih. Duge su to godine, ali i lepe. I još jednom hvala što ste sa nama i danas. Kao predsjednik Saveza mašinskih i elektrotehničkih inženjera i tehničara Srbije SMEIC, prenosim iskrene čestitke i najbolje želje za uspešan rad kongresa u ime svih stručnih društava i kolektivnih članica u sastavu Saveza. Društvo za KGH Srbije, osnovano 1970. godine, kao organizator skupova o KGH i izdavač časopisa KGH, doprinosilo je i doprinosi razvoju i ugledu samog SMEIC-a. Dozvolite mi sada da se u najkraćem osvrnem na istorijat dosadašnjih kongresa o KGH. Prvi seminar o klimatizaciji visokog pritiska i automatskoj regulaciji klimatizacionih postrojenja održan je novembra 1970. godine u Građevinskom centru u Beogradu sa oko 200 učesnika. Uspeh ovog seminara ohrabrio je inicijatore da se naredne godine organizuje drugi seminar, a zatim sledeće godine i treći seminar i da skup postane tradicionalan sve do današnjeg dana. Treba ovom prilikom istaći vizionarski doprinos profesora Branislava Đakovića, predsjednika SMEIC-a, i veliku podršku profesora Milorada Uroševića i profesora Save Vujića. Uz nesebično angažovanje i posvećenost tada mladog docenta Branislava Todorovića postavljeni su čvrsti temelji ovog skupa. 1978. godine skup se seli u Sava centar, a 9. seminar o KGH okuplja preko 900 učesnika, što predstavlja svojevrstan rekord za skupove iz termotehnike u našoj zemlji uopšte. 11. seminar o KGH, održan 1980. godine, ostaje upamćen po rekordnom broju slušalaca jednog predavanja na skupovima o KGH. Predavač i gost bio je čuveni profesor Frank Bošnjaković sa predavanjem na temu termodinamičke analize prijemnika toplote. 1984. godine seminar dobija naziv Kongres o KGH i kao takav postaje prepoznatljiv u Evropi i u svetu. Skupovi o KGH održavaju se stalno u Beogradu. Jedino je 20. kongres o KGH 1989. godine održan u Sarajevu zajedno sa drugim svetskim kongresom Klima 2000 u organizaciji Federacije evropskih društava za grejanje i ventilaciju RIVA. Kongres su podržale vodeće svetske asocijacije Američko društvo za grejanje i klimatizaciju ASHRAE i Međunarodni institut za hlađenje IIR. I danas RIVA, ASHRAE i IIR podržavaju naš kongres na najvišem nivou. Seminar o KGH i potonji kongres o KGH imali su međunarodni karakter od samog početka. Učesnici kongresa bili su priznati stručnjaci iz inostranstva, kako sa vodećih univerziteta, tako i iz svetskih kompanija koje su diktirale razvoj i proizvodnju opreme u ovim oblastima. 50. kongres održan je 2019. godine u Sava centru i obeležen je kako dolikuje velikom jubileju. Podsjetimo se još jednom kako je najavljeno. Na kraju želim da istaknem da je kongres dao nemerljiv doprinos razvoju nauke i struke o KGH u Srbiji i da zahvalim svim istinskim privrženicima struke KGH, svim našim sponzorima i svima koji su predano radili na organizaciji, što su učinili da kongres o KGH bude zalog profesije generacijama koje dolaze. Povodom jubilarnog 55. Međunarodnog kongresa i izložbe o KGH, a na predlog Upravnog odbora Društva za KGH Srbije, Upravni odbor Smejica na svojoj 6. sednici 2. avgusta 2024. godine doneo je odluku o dodeli jednokratnog priznanja za izuzetan doprinos struci KGH povodu ovog kongresa. Molim kolegu Slobodana Pejkovića, člana Upravnog odbora Društva za KGH Srbije, da uruči priznanja.
Dame i gospodo, cenjene koleginice i kolege, meni je velika čast da ja mogu da budem taj koji će da uruči ta priznanja ljudima koji su vrlo zaslužni za održavanje ove manifestacije. Ove godine smo doneli odluku, 55. je ipak jubilarni, doneli smo odluku da samo dva pojedinca i jedna firma dobiju to priznanje i da na taj način uvećamo ili uveličamo ovaj skup. Ponosan sam što mogu danas da uručim ovo priznanje profesoru Todoroviću, koji je godinama, više od 50 godina, bio moj učitelj. Ja se trudio, ali baš ne mnogo uspešno, da ga kopiram. On je imao najznačajniju ulogu u ostvarenju uspeha društva za KGH i samog kongresa. Bez njegovog entuzijazma i posvećenosti mi ne bi danas bili ovde. U svoje ime i u ime svih prisutnih želim da izrazim najdublju zahvalnost za sve što je učinio i čini za uspeh našeg društva i kongresa. Sretni smo što ga imamo kao kolegu i kao prijatelja. Čestitam profesore Todoroviću i uručujem vam ovo priznanje.
samo da se zahvalim na pažnji i veliko vam hvala. To me baš tirnulo. Stvarno ovo je, ja ni sam ne znam koji je meni kongres po redu. Kad smo počeli da brojimo, bilo je to davno.
Da, da.
Podsjetit ćemo se.
Da. Hvala vam. Hvala vam još jednom na svemu što ste do sada učinili za ovo društvo i nadam se da ćete i dalje da budete sa nama i da ćete moći da date svoj doprinos organizaciji ovog skupa. Drugi dobitnik priznanja je gospodin Alex Pačaj. It gives me a great pleasure to present this recognition today to someone who has made a significant contribution to the work of the KGH Society. Over the past 15 years, his presence and outstanding presentations have played an important role in making our Congress a significant event in the region. On behalf of the entire society, I would like to express our deepest gratitude for everything he has done and continues to do for the success of our Congress. We are happy to have him as a colleague and a friend. It's my honor to present this well-designed recognition, desired recognition to Mr. Pačaj. Na kraju mi imamo jednu firmu koja je dobila ovo priznanje, jedna firma koja je godinama sa nama prisutna, ja sad ne znam da li je to 30, 40 ili više godina, nije ni bitno, ali to je jedna od firmi koja podržava i koja sponzoriše naš kongres. Mnoge firme su zaslužne za održavanje ovakve manifestacije i u ovom obimu i sa ovim značajem, ali nismo mogli svim firmama da damo, ja ne bih sad ni pominjao te firme koje su, predstavnici tih firmi su ovde prisutni, ali smo izabrali Trox i naša koleginica Irena, koja je godinama predstavnik Troxa za Srbiju i za ovaj region, će primiti to priznanje u ime Troxa. Ja bih još jednom zahvalio svim sponzorima koji podržavaju naš kongres i koji nam pomažu da mi održimo to u ovom obimu i u ovom značaju. Molim koleginicu Irenu da dođe.
Zahvalila bih se u ime kompanije Trox i u svoje lično ime na ovom lepom priznanju koje doživljavam kao jedan znak da je kompanija Trox u periodu od preko 50 godina koliko je prisutna na ovom tržištu dala svoj skromni doprinos razvoju ove struke. Hvala vam.
Edukacija studenata za struku KGH i naučni rad u oblasti termotehnike organizovani su na fakultetima u Srbiji vrlo brzo po njihovom osnivanju. Mladi inženjeri opredeljeni za struku KGH obrazuju se na fakultetima u Beogradu, Nišu, Novom Sadu, Kragujevcu i Kraljevu. Molim profesora Slobodana Savića, dekana Fakulteta inženjerskih nauka Univerziteta u Kragujevcu, da nam se obrati. Profesor, izvolite.
Hvala lepo. uvaženi domaćini i učesnici 55. kongresa i izložbe o KGH. Čast mi je i zadovoljstvo da vam se obratim u ime Fakulteta inženjerskih nauka Univerziteta u Kragujevcu, na kome sam dekan. Istovremeno, prenosim vam srdačne pozdrave dekana, odnosno rukovodstava svih mašinskih fakulteta Republike Srbije. Fakultet inženjerskih nauka Univerziteta u Kragujevcu, ranije do 2011. godine Mašinski fakultet, ima dugu tradiciju saradnje i učestvovanja u aktivnostima Društva za KGH i Saveza mašinskih i elektrotehničkih inženjera i tehničara Srbije. Podsjetit ću da je Katedra za energetiku i procesnu tehniku na našem fakultetu osnovana 1987. godine i da su paralelno sa nastankom katedre započele i studije na smeru za energetiku i procesnu tehniku. Prvi članovi katedre bili su profesori Svetislav Stojković, Milun Babić i Milorad Bojić. Akademskoj zajednici su svakako poznati, impozantni i visoko citirani rezultati naučnog rada prerano preminulog profesora, dugogodišnjeg upravnika Centra za grejanje, klimatizaciju i sunčevu energiju i, sa ponosom ističem, akademika Milorada Bojića. Upravo zahvaljujući takvim pionirima istraživanja, saradnje sa privredom i međunarodne saradnje u polju energetike i procesne tehnike i zahvaljujući nastavljačima njihovog dela, ova oblast delovanja Fakulteta inženjerskih nauka je i danas prepoznatljiva i daje rezultate kako u akademskom, tako i u privrednom okruženju. Verujem da će se sve kolege sa mašinskih, odnosno tehničkih fakulteta u Srbiji složiti da je saradnja sa našim domaćinima uvek konstruktivan i produktivan proces, ali istovremeno i srdačno prijateljstvo. Beogradski kongres sa izložbom o KGH odavno je stekao i učvrstio reputaciju manifestacije koja postiče analitičan pristup aktuelnim temama i problemima u nauci i struci KGH i bavljenje najvažnijim pitanjima, pre svega pitanjima energetike i zaštite životne sredine. Sadržaj i odlična organizacija programa iz godine u godinu privlače veliki broj učesnika i gostiju iz svih krajeva sveta, a interesovanja i oblasti istraživanja i rada očekivano se prepliću i sa drugim područjima, poput građevinarstva i arhitekture. Značaj kongresa KGH je ne samo u tome što uspešno okuplja istraživače i profesionalce struke oko značajnih tema, već i u tome što generisano znanje zatim pronalazi svoj put do novih generacija đaka, studenata i mladih inženjera i naučnih istraživača. U širokom polju inženjerstva sve nas povezuje nastojanje da iz godine u godinu agilno i proaktivno reagujemo na dinamične promene u užem i širem okruženju. Buduće inženjere moramo pripremljene ispratiti u svet, koji se menja ubrzanim tempom. Stoga su zahtevi koji se postavljaju pred tehničke, odnosno mašinske fakultete sve kompleksniji. Kao odgovor na navedene izazove pokazalo se upravo negovanje postojećih i uspostavljanje novih partnerstava sa srodnim institucijama i profesionalcima u inženjerskoj struci. Utoliko je i veći značaj kontinuiteta i kvaliteta kongresa o KGH koji se održava već 55. put i okuplja nas oko zajedničkih tema. Zahvaljujem organizatorima na pozivu i gostoprimstvu i ne sumnjam da ćete nas i ovoga puta ispratiti bogatije za nova saznanja, rešenja i aspekte sa kojih se može posmatrati i analizirati aktuelna problematika. Hvala i neka je srećan jubilej.
Zahvaljujem profesoru Saviću i želim puno uspeha u obrazovanju mladih koji će posle toga biti naši kolege i nastavljati ovo zajedno sa nama, uključujući i sve članove akademske zajednice u Srbiji. SMEIC, Društvo za KGH, punopravni je član Evropske federacije društava za KGH Riva već dugi niz godina. Molim profesora Katalina Lungoa, predsjednika Rive, da nam se obrati. Please.
Thank you for this great opportunity to address KGH audience today. Probably you know that it will be the last time when I'll address the audience as the Riva president, and that's why I wanted to say something meaningful for all of you, for Professor Todorovic, for Professor and President Blagojevic, and for all my friends in Serbia. So I have written some ideas, and I hope you don't mind if I read all these ideas. So it is an absolute pleasure and privilege to welcome you all on behalf of Riva to the 55th KGH Congress and exhibition in the vibrant city of Belgrade. As a Romanian, I feel a deep sense of connection and worth standing here in a region where our histories have been intertwined for centuries. The friendship between Serbia and Romania is not just a fact of geography, it's a story of shared culture, mutual respect, and countless glasses of wine exchanged over lively debates. As always, your Congress, so well known nationally and also internationally, embodies the spirit of collaboration, bringing together bright minds from across disciplines, engineers, architects, contractors, professors, real estate developers, and even, dare I say, our friends from ASHRE, who keep reminding us that HVAC, decarbonization, buildings, sustainability are definitely an international affair. We are all part of a global community shaping not only how buildings work, but how they breathe, live, and serve their occupants for wellness and health. Events like this are critical to the building services subsector of the construction industry. They remind us that while we may work in separate offices and countries, we share one ultimate goal: creating comfortable, healthy, and sustainable environments for people to thrive in. Over the past 3 years, Riva has been laser-focused on empowering professionals like you with the tools, knowledge, and networks to meet today's challenges. So please let me share a few highlights about our guidebooks, EUPAG, EU projects, and international cooperation. So something about guidebooks. We have released guidebooks 34, Instantaneous Wastewater Heat Recovery in Buildings, and then the guidebook 33, Resilient Cooling Design Guidelines. And also this year, the report replacement of gas boilers with heat pumps, district heating, and hybrid solutions. About EUPAG, the European Policy Advocacy Group. So we launched this group in 2024 to give the HVAC industry a louder voice in shaping EU policies. And let me tell you, navigating Brussels isn't for the faint-hearted. But EUPAG has made remarkable strides, influencing key legislation like the Energy Performance of Buildings Directive. Then about EU projects, so we are proud partners in more than 10 EU research projects, pushing the boundaries of what's possible in energy performance and building technologies. The EPB Center is another example, a hub of expertise helping countries implement performance-based standards effectively. Then the international cooperation, so from the HR Expo in the US to Climate Congress and international standards work with the CEN, RIVA is ensuring that European expertise is not just heard but sought after on the global stage. So the KGH Congress itself is a shining example of the power of events like this. It's not just about exchanging technical knowledge, though there will be plenty of that these days. It's about fostering a sense of community. It's about finding common solutions to shared challenges, and yes, it's about making lifelong friends. So speaking of friends, let's acknowledge the diversity in this room. So from engineers who make magic happen with the airflows, architects who turn dreams into blueprints, contractors who bring plans to life, developers who turn risks into opportunities, and professors who inspire the next generations. You are the breathing heart of this industry, and your contributions are invaluable. So before I finish my speech, let me leave you with a thought. What we do might not always be visible. No one ever walks into a building and says, "Whoa, what a beautiful designed HVAC system," but our impact is profound. We create spaces that are comfortable, healthy, sustainable, spaces where people can dream, innovate, and thrive. So let us make the most of this Congress. Let us inspire the other people, the other specialists, and in the end, hvala vam puno, mulțumesc mult. Thank you very much for your attention.
Zahvaljujemo profesoru Lungu na lepim rečima. Thank you. Dugogodišnja saradnja sa Američkom asocijacijom inženjera za grejanje, hlađenje i klimatizaciju ASHRAE institucionalizovana je kroz članstvo Društva za KGH u alijansi pridruženih članica i kroz individualno članstvo naših inženjera. Molim profesorku Mahrut Eftehari, direktorku ASHRAE Evropskog regiona 14, da nam se obrati. Profesorka, please, the floor is yours.
Thank you very much, Bata. Hello, everybody. I'm Ru. I'm the Director and Regional Chair, DRC, for ASHRAE European Region 14. For my day job, I'm a professor and course director at Loughborough University, UK. I teach building services engineering, thermodynamics, and refrigeration systems. As you might know, the European region was formed in order to create more collaboration and working with the local association. ASHRAE is a global society with a mission to serve the humanity. And same as RIVA, ASHRAE provides tools to achieve net zero. I don't need to understand your language to know that this 55 Congress of HVACR and exhibition is very important, and you guys are very passionate and dedicated to our industry. Thank you very much. I would like to thank all of you for your dedication and passion to our industry. We are going to make a big difference and achieve net zero through the collaboration. I look around the building and look at all of you, and I can see that we have got a future for collaboration. This is my vision as a DRC, to have collaboration and meetings like this across Europe. We need to collaborate with each other. We need to exchange ideas. And students and young engineers are an important part of achieving decarbonization and net zero. So I will urge all the local associations across Europe, please let's work together. Please let's collaborate. Let's exchange ideas across the whole sector. We need to be multidisciplinary. We need to work together. We need to have engineers, architects, contractors, everybody, chemists, business, because decarbonization is a business factor. We need all of us to put our ideas together because we have no other choice. By 2050, we need to be global net zero. So my message is collaboration, working together, and having more meetings and exhibitions and congress like this. So I salute you, and I'm very privileged to be here and be part of this community. Let's have fun, also learn from each other, and make new friends. Thank you.
Thank you, Professor Eftekhari. Thank you very much. And welcome to Belgrade and to Serbia. Na inicijativu profesora Branislava Todorovića i profesora Floreje Kirijaka, članovi Ašera iz Srbije i Rumunije, zajedno sa članovima iz podunavskih zemalja, osnivaju 2005. godine Dunavski ogranak sa sedištem u Temišvaru. Saradnja sa Asocijacijom inženjera za instalacije Rumunije AIR danas je veoma uspešna na profesionalnom planu, kao i u ličnim prijateljstvima. Molim doktora Joana Silviju Dobošija, predsjednika AIR-a, da nam se obrati.
Dear Mr. President of KGH, Professor Bratislav Todorović, dear Mr. President of SMATES, Professor Bratislav Blagojevic, ladies and gentlemen. Celebrating 55 years of existence is a special moment in the life of the professional organization. This means tradition and professionalism alike. The event has an emotional charge, especially when we note that all 55 editions of the conferences were chaired by Professor Branislav Todorović. On behalf of the delegation of the Romanian Association of Building Services Engineers, please accept, Professor, our full consideration. I bring before you the collegial greeting of the Building Services Engineer from Romania. I want to thank Professor Bratislav Blagojevic, Professor Marko Ignjatovic, and Mr. Vladan Galevovic for the hospitality with which they surround us every time we come to this Congress. It's been 20 years since I came to the KGH Congress for the first time. Since then, KGH, together with AIR, is an important professional turning board in Eastern Europe. If Romania is a member of RIVA since 1985, it is due to the friendship between Professor Branislav Todorovic and Professor Florea Chiriac. The same friendship determined that in 2005, in April 8 in Timișoara, the Danube-ASHRAE chapter, the second oldest chapter in Europe, was established. A proof of the steadfastness of the joint work between KGH and IIR is the presence at this Congress of the President of RIVA, Professor Cătălin Lungu, and Region 14 ASHRAE DRC, Professor Maru Eftekari. Our common objective is the promotion of young people in the profession we represent. It is already become tradition to organize student competition, both within RIVA and within ASHRAE. Tomorrow is a day dedicated to young students and engineers in building services, and there will be an exchange of experience between students from Professional University from Serbia and students from Politehnica University of Timișoara. Important topics such as energy efficiency, comfort, decarbonization, sustainability will be addressed and debated. Because I was talking about tradition at the beginning of my speech, it's given my great pleasure to extend to all colleagues from Serbia and those from abroad present at this conference the invitation to participate to the 60th Jubilee edition of the AIIR conference from October 12 to 14, 2025. Please let's watch together the promotional movie of this major event for our association. Please.
Este o mare bucurie, în același timp o emoție împărtășită cu toți, pentru faptul că am revenit la Sinaia. Conferința Asociației Inginerilor de Instalații din România a revenit acasă.
Today we have gathered to discuss the latest advancements and innovations addressing a growing challenge that affects us all, the urgent need for environmental sustainability.
A paradigm shift is unavoidable, and I refer here the title of our conference. The transition from traditional to sustainable solutions requires not only technological innovation, but also an evolution of professional skills.
14 octombrie este Ziua Mondială a Standardizării. Ce poate fi mai frumos pentru noi, standardizatorii, de a fi prezenți la o reuniune atât de importantă a partenerilor noștri, să vorbim despre standardizare, să vorbim despre educație în domeniul standardizării.
Chiar dacă este a 59-a ediție, este poate ediția care are o mare parte de oameni tineri, de ingineri tineri, de viitori tineri.
Mă bucur să văd o comunitate atât de numeroasă, diversă și unită. Este un exemplu de modul în care trebuie să existe o breaslă și să funcționeze o breaslă. În același timp, un exemplu și despre cum trebuie organizată o conferință.
My warmest salutations from ASHRAE. As you know, ASHRAE is an American society by name, but it is a global organization, and we try to work together with many other organizations.
Cu gândul la cea de 60-a conferință, vă doresc multă sănătate, vă doresc prosperitate și să ne vedem cu bine la anul, între 12 și 14 octombrie, și să ne bucurăm de familia inginerilor de instalații pe care o constituim.
How you saw, also we are a big family of building services engineers, and I'm very proud that in the last edition, more than 300 attendance we had on the conference, and 85 students were also present at the conference, which we will see also, we will have here tomorrow. I wish the work of the conference much success. Thank you very much.
Thank you, Jon. Thank you very much. Hope we will be together next October in Sinaia. Kompanija Elcom Trade iz Beograda, osnovana 2003. godine, bavi se uvozom i distribucijom uređaja za klimatizaciju. Od osnivanja kontinuirano je prisutna na izložbi koja prati kongres i pomaže sve aktivnosti na kongresu. Na ovom 55. kongresu Elcom Trade je generalni pokrovitelj. Molim predstavnicu kompanije da nam se obrati. Izvolite.
Poštovano predstavništvo, uvaženi gosti kao i kolege organizacionog odbora koji nam po 55. put omogućavaju KGH skup. Čast nam je da vas pozdravimo u ime generalnog pokrovitelja Elcom Trade. Elcom Trade postoji od 2003. godine i osnovna delatnost je klimatizacija, grejanja i hlađenja. Gotovo od samog osnivanja firme prisustvujemo na skupovima KGH. Velika zahvalnost predsjedništvu i organizacionom odboru za mogućnost ovakvih skupova gde imamo priliku da se upoznamo sa novim dostignućima iz oblasti KGH. Ukratko bih vas upoznala sa dva brenda, Midea i Daikin, koje Elcom Trade zastupa i distribuira. Segment klimatizacije Midea započinje u svojoj fabrici 1985. godine. Već 1990. potpisuje ugovor sa Toshibom u pogledu zajedničkog razvoja tehnologije i započinje proizvodnju split sistema. 8 godina kasnije kupuje Makro Toshiba fabriku kompresora, koja će kasnije biti preimenovana u GMCC i koje su sada zastupljene u velikom broju drugih klima uređaja. 2004. godina je posebno važna za razvoj Midea, jer tada su ostvarena dva važna partnerstva. Sa Toshiba Kerijama u cilju da proizvodnje klime uređaj i osnaživanje istraživačkih kapaciteta u menadžmentu i proizvodnji i sa Chongqing Generalom za proizvodnju i distribuciju komercijalne opreme. Dalji razvoj proizvodnje nastavlja se ubrzano i uzlaznom putanjom. 2007. godine Midea osniva svoju prvu prekookeansku greenfield investiciju u Vijetnamu. 2010. godine sa Kerijom kupuje trećinu egipatske fabrike Mirakom. 2011. godine takođe sa Kerijorom otvara 3 fabrike u Latinskoj Americi. U 2014. godini Midea ostvaruje najveći promet ikada, $23 milijarde, od čega 1/3 ostvarena plasmanom prekookeanske prodaje. Možemo se pohvaliti da u 2024. taj promet iznosi preko $50 milijardi. Pored sjajnih rezultata, iste godine je obeležila instalacija VRF sistema na stadionu BREO, na kome se održalo svetsko prvenstvo 2014. godine u Brazilu. 2017. godina obeležila godinu kad je Midea kupila KUKA robotiku, a u 2018. godini za svetsko prvenstvo u fudbalu, koje se održalo u Rusiji od 12 fudbalskih stadiona, Midea klimatizovala većinu. U 2024. godine raspolaže se preko 10 proizvodnih pogona širom sveta. Takođe, Midea posjeduje 31 inovacionih centara sa više od 10.000 zaposlenih. Sa ponosom ističemo da u pogledu razvoja i dostignuća Midea prati trendove i energetski efikasnost u održavanju razvoja gde koriste gasove sa do sada najnižim uticajem na ozonski omotač. Napomenula bi da Midea drži 35.000 patenata i investicije u R&D u vrednosti od $4 milijarde. Takođe bi rekla par reči o Daikinu. Daikin je prvi pionir u projektovanju vrhunske tehnologije i klimatizacije još od nastanka ove industrije. Tokom godine Daikin je stekao ogromno iskustvo u ključnim tehnologijama za kontrolu klimatizacije, kao što su toplotne pumpe, inverteri i rashladni fluidi. Daikin je zapravo jedini proizvođač koji je samostalno usavršio ove tehnologije. Te tehnologije sada nalaze mnogo širu primjenu u vidu integrisane, potpuno udobnosti i industrijska rešenja koje su energetski efikasnije i emituju manje štetnih gasova. Kompanija Daikin Europe je predvodnik ovog trenda šire primene i integracije, što se ogleda i u 4 stuba njegove poslovanja: grejanje, klimatizacije, namenskih sistema i hlađenja. Od kako je kompanija Daikin Industries počela 50. godina 20. veka da proizvodi toplotne pumpe i klima uređaje, rešenja za kontrolu klimatizacije obuhvatile su komercijalne, industrijske i kućne primene, uključujući i ultraefikasne sisteme grejanja stambenih objekata. Daikin je preko 80 godina prisutan u svim tržišnim segmentima sa inovativnim, energetski efikasnim i pionirskim proizvodima, sa regulisanjem klimatizacije koje su prilagođene potrebama klijenata, od kućnih uređaja za domove, kancelarije ili prodavnice do malih i velikih komercijalnih uređaja za hotele, restorane i apartmane industrijskih namena. Svi proizvodi su projektovani imajući u vidu očuvavanje životne sredine. Korišćenje su najbezbedniji materijali, a sistemi i postupci koriste bezbedne rukovanje kritičnim komponentama poput rashladnih fluida. Pravilno odlaganje i recikliranje svojih komponenata na kraju radnog veka osmišljeno od samog početka. Kompanija Daikin je potpuno svesna svoje odgovornosti prema životnoj sredini i posvećena je tome da domovima, firmama i industriji pruži najefikasniju, najbezbednije proizvode koji ispunjavaju sve njihove zahteve u pogledu hlađenja, grejanja, kako danas, tako i u budućnosti. Daikin proizvodi su lideri niskoenergetske potrošnje, inovacije, dodatno smanjuju uticaj HVAC i uređaja na životna sredina. Elcom Trade je ponosan što može sebe nazvati partnerom obe kompanije, samim tim je i naša odgovornost veća. U ime Elcom Trade firme zahvaljujem se svima koji ličnim trudom i zalaganjem čine ovaj stručni sajam mogućim i nadamo se da ćemo i u budući imati prilike da se okupljamo. I za kraj svima ću poželiti puno uspeha na poslovnom planu u 2025. godini.
Hvala lepo. Koleginice, samo jedan trenutak, molim vas. Zamolio bih profesora Milovana Živkovića, potpredsjednika Smejica, da uruči zahvalnicu našem generalnom pokrovitelju Elcom Trade-u. Koristim također ovu priliku da i lično pozdravim, odnosno da pozdravimo Dragana Arsenovića, vlasnika i osnivača Elcom Trade-a. Hvala. Hvala lepo. Poštovani učesnici, ovim je ceremonija svečanog otvaranja završena. Želim vam uspešan rad na kongresu i na izložbi, ugodan boravak i lep provod u našem glavnom gradu. Zatim nastavljamo. Hvala, još jednom. Hvala svima. A sada nastavljamo sa plenarnim predavanjima. Po našem programu, prvo predavanje pod nazivom Šta za mene znači Evropska direktiva, šta za mene znači Evropska direktiva 2024/573. Kolega Aleks Pačaj, izvolite.
Pačaj. He doesn't have it? Ah. Thanks. The one. Version 1. Yep. I will entertain you a little bit with a little bit about the European F-gas directive. You probably saw it, but there can also be some learnings from this third EU F-gas legislation. I suppose you have been following this over the years. This bloody light, if you could turn this down a little bit. You cannot? Hmm. Okay. Anyway, the main purpose of the directive is to regulate the organic, that organize the quota system, because there has been a lot of criticism around the quota system and also the illegal trade. You probably followed how they have been confiscating around in Europe from different sources. Also, they are looking at the F-gas, and there are actually some bans also on the so-called HFOs, or unsaturated F-gases, or HFCs as they are called in the directive, but not everybody sees it. Also, they want to do a lot of monitoring, or where is the gas at any time, who has it, who bought it. So in this way, to control the illegal trade, because the more documentation, the more transparency gives less possibilities to do things that are best hidden in the darkness, so to say. And also there is a lot of control and phase down, and the phase down is much more challenging than a lot of people they think, and by 2030 there will not be enough HFC on the market to serve just for topping up from leakages. So all new or virgin HFC coming to the market from 2030 should be reserved for new for new systems, topping up only, and new systems should only be on alternative solutions, and be careful, because investing in systems that will be banned shortly after is not very smart. So the F-gas story started already in 2006. There was a lot of debates, a lot of meetings, both in Brussels and elsewhere. I traveled to a lot of them. And then came the second one in 2014, which was a little bit tightening up the grip. And the new one is then called 573 from 2024. And this is the one that we are looking at. And there is actually also what a lot of people, they oversee, is that there are a lot of implementing acts. I will show them here, but I will not list them all, because there's quite a lot. Actually, there was also, for the other directives, the old ones, there was also implementing acts which were put in place, but not everybody was reading it, because it's quite a book. The contents of the regulation, I've tried to organize it a little bit here, saying that the articles by introduction, containment, and all this, and you can see the list. But it is quite a long directive, and there is a pre-text before the actual regulation comes, which you should also try to look through. I know it's a little bit boring, but it is also important, some of the text. The new regulation went into force in March 24, after 20 days of publication time. 5 minutes or what? Oh, okay, thank you. And there is also these implementing acts. Some of them have gone into force, and some of them are coming into force. And some of them have been there all the time, because they are not changed since the old one. Also, there is a lot of changes in the certification systems. Suddenly now the natural refrigerants, CO2, ammonia, and hydrocarbons have come into the F-gas legislation, which has created a lot of disturbance, because we already had this under the PED. So that's why it's a little bit complicated to understand how it hangs together, and I don't know if the Commission has thought this very cleverly through, but we can always debate that after the presentation. And most important things is to notice that if they don't say after a ban refer to an annex, then it's actually all three annexes. It's very important to read and understand that. I will come back to that with an example here. And after, I said it before. About retrofitting, actually the PED is actually the regulation you have to look at. And when you go with the retrofitting of HFCs to other fluids, which it was actually not designed for, you are actually going into a dangerous area, because you have to verify or document that the components and the materials are all they are compatible was the word, with the new system. And you have to document it, and if it is a system that is 10 or 15 years old, it can actually be difficult to get the documents, so you have to do tests, and at the end of the day, retrofitting a system that is designed for so-called non-flammable gases into something that is A2L, it's not that easy. So my recommendation is think it very carefully through before you start looking at retrofitting, because it can be costly and complicated. So very often, then just forget it. Leak checks is also something that is in the new directive, but it's more or less the same. Just there has come a new perspective into it, because you cannot use the GWP as a measure to when and what, so they have come with this dual system. So you have for HFCs and you have for the UHFCs, means unsaturated HFCs. And that is why it is a little bit more longer than it used to be, but it's more or less the same as it was before. And here you have the phase out, and that means phase out of the fluorinated gases, and that is from 2050. But what you will notice is that this changed a little bit from the existing 517, means the old directive. It's accelerated the phase down. So what is placed on the market is less than it was supposed to be if we had followed the 517 to the 573. And you can see it's quite steep. And the 9 million ton CO2 equivalents is less than we will need for topping up after leakages. And here is how it looks. If we had followed the blue line, which was the old directive from 2014, we will have ended here, but you can see now with the new directive, we are going steeper in the placing on the market or available on the market. It becomes less very quickly. And then it becomes a matter of who is willing to pay the highest price for the refrigerant. So it becomes a market pricing discussion. And what you also will notice in the new directive is that other players or systems are come into meaning the medical inhalers. I know it's not very big amounts, but when we have cut down, as we have in this directive, the 14,000 tons that they are using for inhalers is actually a significant part of what we will have available. Also trucks and cars, their chunk of the HFC is included here, and also for the ORC and all these kind of systems. So there is there is a number of other applications that have come into play here, which will actually mean that what we thought was available to refrigeration and heat pumps is less than we think. So be careful. The requirements are growing, and in the good old days, a lot of people, they work with reduced training because you could do it, and also there was a lot of cowboys in the market, which has always been a discussion topic. But now the grip is tightening because that the basic, it is with HFCs and HCs, you get a certificate for that. They are put those two together. And that's why that the old certification system where you had for the small charges now allows you to work with HC systems with no limit in capacity. So it means a requalifications of those who are working with HFC, and even at low certification, needs to know more, better trained, and also a wider trained, because now they are working both with HFCs and HCs. CO2 and ammonia will be driven more by PED and by the manufacturers. I believe very much in that a lot of the education and training of service technicians will actually move from schools, because they are not as fast to change direction, and there is no one way for the control of the systems. So you need to know specifically about the products that you are selling, because a rack is a rack and compressor is a compressor. But the controls are very different from one manufacturer to the next, and therefore the manufacturers will have to step up and educate, and they already do. It's not something new, just that we need to document that we were there, we have the training, we can do it. Because qualification is one thing, but you also need to document you have it. It's a lot about documentation, I know it, but that's it. Also, the directive asks for updates and requalification after 7 years, but we are a little bit in doubt if it is only for HFC qualifications or if it goes for all the rest, because I know from real world that people that have worked with with CO2 and ammonia know more than any school guys know. And also here, implementing the 2215 is very important, because that is actually the implementation of the certification. And that is the implementing act about this topic. And it says, it defines what you have to do, it defines the jobs and all this. And there is actually very similar to the ISO 22712, which is the qualification standard for refrigeration and heat pumps. And that is even very, very important, because that is very specific on what does a design engineer need to know, what does a contractor need to know, what does the service technician need to know, what does the leak check technician need to know, and all this. It's much more detailed, and it's very valuable. I'm not saying it's a textbook, but it just says you need to know about this and this to this level, and other things not so high and all this. Very important. Then you can read it later. It is about the works, and it goes into the certification system. Then there is this word, the natural person. I hate it, because who is not a natural person? But it means actually a competent person in this certification system. If you are competent according to the EN 378, then you can work. And competent is, again, if you have the certificates to work with what you have to do. Here it says a natural person of the EU means a national is what you call it, a citizen of a member country, and you have to follow this, and therefore, and then there is also a little bit if you are working in different, you are effective nationality. About natural refrigerants, it's important to understand that the natural refrigerants are regulated under Here, there is actually a zero too much in this. I can see that now. But there are the implementing acts, and they are actually regulated under PED and ATEX, the ammonia and CO2 systems, more than they are actually regulated in the F-gas legislation. Therefore, the certificate has to be somehow taking this into account. But they are integrated to see that it is hanging together somehow. And then there is all this about the legal persons. It's a different thing, but it's about who holds the certificate for the company and all this. And you can find that in Article 7. And this is about that the employer has to have equipment and tools, and you have to prove it. How they will follow that up, I don't know. But it's a practical thing. And what about the existing certificates? Because that's a big issue. But the good news is that we can keep on using those until the new the system goes into force, and then we need to perhaps change the certificates a little bit so it reflects what it has to do. Then here is the list of the implementing acts, and I know that you cannot read them, or perhaps you can, but anyway, there is a lot of them, and some of them are less relevant for refrigeration because, again, it is covering other things as well and other fluids that are not relevant. How are things actually developing? Because I looked at how is, because the main exercise is to make the consumption go down. And we can see that the consumption of 134A is actually falling over the last decades. You can see that from 2014-15, it has fallen down to about half, approximately. We can also see that the so-called UHFOs are actually increasing. The yellow in 2023 is a kind of guess, because I've taken the last 3 years because the data is not available in the report from the European Environment Agency. But I try to use the same split between the YF and the rest. The rest, I don't know what it is, because there's too little. It means the ZE and all the other UHFCs. But you can see that the consumption is also increasing for R32, but R32 will be regulated under the GWP rules in the directive, so that will start kicking in the new directive. So the bans, there is a lot of them. Some of them you know already because they've been in place since 2007, it says here. And there is a lot of them. I will not read all of them for you because you can do it yourself, because you have to know your own system. What is very important is that if it says, for example here, split air-to-air systems and containing functioning on fluorinated greenhouse gases with GWP of 150 and more. And when they say it like this, there is no reference to an annex. So it means all annexes. It's very important. And not everybody sees it, but it is how it is. That means that for split air conditioners, there will be a ban in a few years' time. 2027 is not very far away. I tried to sum it up a little bit differently because it makes, at least for me, a little bit more easy to see. And when it says no F-gas, means it's all annexes. So effectively, they are banning the so-called HFOs in some applications. There is one more thing. They say if you can use higher GWP if it is required for safety. But it is a system by system exemption you get, and the paper with the exemption has to be kept by the system as long as it's standing at the site. As soon as you move it, it's a new story and a new evaluation. But you cannot give a blank exemption for a system, type of system. So you can use it, but be careful, it's not so easy. You have to document a lot and why you are using it. So you have here the first phase out, and then comes the second one, and you can see that it's going to be tough if you hold it up against the phase out. So the bans, they are there are bans for other things that are not related to I didn't take all the bans because there are some for other things that is not related to refrigeration or heat pumps. But a lot of the manufacturers in Europe, they have understood the message, and we could see that at the last Chilventa in October 24, that they are moving. We saw propane overall. There was a few R32 and one for 10A, as I could see it, and I was running around a little bit, so I saw it. And the focus on propane is just one of them. There is, of course, also still ammonia and CO2. CO2 is also picking up, and both in commercial system, but also in larger district heating, heat pump systems, and so on. And ammonia has always had a big part of the industrial markets. So there will be a lot of it. So we are standing actually in a kind of perfect storm. We are talking about the ozone layer because there is actually some of the breakdown products that end up as ozone depleting substances in the atmosphere, and the hole is not closing as fast as they thought it would. Actually, it's growing. According to the OECD PFAS definition, there is more than 7 million of these compounds if we include the breakdown products. There's only 6.5 million PFAS, but with the breakdown products you come over the 7 million. That means, for example, TFA, which is one of the big problems we are facing, that can cause everything from cancer to Alzheimer to Parkinson, dementia, ADHD, etc. So there is a lot of things going on. So we are standing also in a chemical crisis. And then we have a climate change. We have seen all the floodings and all this caused by greenhouse gases of different kinds, and therefore, and then we stand in a kind of plastic pollution crisis. And the humans are the cause. They have caused this, and the humans are also the ones that have to fix it if the politicians will act. Thank you for your attention.
Thank you, Alex. Thank you very much. We shall continue. I would like to announce our distinguished lecturer, Andy Pearson. Zamolio bih kolegu Andy Pearsona da nam izloži predavanje pod nazivom Putovanje u bolji svet, perspektive u oblasti hlađenja. Okay, the floor is yours. Thank you.
Thank you very much, and good morning, everybody. Firstly, I would like to bring you greetings and congratulations from the Institute of Refrigeration in the United Kingdom. 55 years is spectacular, absolutely fantastic. So to KGH, to the Congress, and to Smeets, our hearty congratulations, fantastic. I want to talk a little bit about our journey to a better world and give a refrigeration perspective. This is essentially the same message as Alex has just delivered, but perhaps coming from a slightly different angle. So hopefully we'll continue to give you food for thought and some topics that you can take away for consideration. But I thought I would start by giving you my credentials for presenting this talk, because I'm one of only 8,194,748,000 people in the world that could have been asked to come and give this talk. In 1962, when I was born, I was one of only 3,188,000,000 people. So I feel that my stock is kind of diminished over the years. You know, I'm a smaller piece in a bigger machine. And yet, my first paid employment in refrigeration was not as old as Kage-ha, but in July 1973. My connection with refrigeration goes back further because my father and my grandfather were both refrigeration engineers. So actually, although born in 1962, I can look back to 1935 and experiences from there with my grandfather. And my career has given me really rare opportunities to observe industrial refrigeration all over the world. So in that sense, really, I'm the only one person who could give this presentation because it's very much a personal view. And that means that if you disagree with me, that's okay. I would like to hear from you. I'd like to have a conversation with you if you don't agree with what I'm saying, because then we can maybe move forwards and develop a synthesis together. But it's very much a personal view. So if you don't like it, that's fine. I'm perfectly happy with that. But come and tell me that you don't like it. Okay, is that a deal? So we're talking about a journey. We're on a journey. We've been talking about various dates so far. You know, 2027 was mentioned, 2030, 2035, 2045, 2050. None of these dates are the destination of this journey. Even 2050, it's just another point along the way. And for the last 40 years, I feel we've been working really, really hard, but just to stand still. All of this refrigerant phase out and churn and change has not actually helped us move towards a more efficient, better world. So we've got a lot of catching up to do. I keep saying to people, especially to students and younger engineers, this is an absolutely fantastic time to be an engineer working in refrigeration because there is so much happening and so much to do. Not like the early days in my career when it was really just, as I say, running hard to stand still. We have a fantastic opportunity now. So that's the journey that we're on, is that development and opportunity. So I want to talk a little bit about the current status on a few of the issues that we've been working on over the last 40 years or more. Ozone restoration, Alex mentioned the job is not done. We're not there yet. But if you look at this graph, this shows the extent of the Antarctic ozone hole with a graph from 1960 to 2100. And you can see that it dipped down because of the ozone depletion problem of the 1980s, 1990s. And it is gradually coming back up. We can say you are here, as the maps would tell you. We're partway on that recovery journey, but there's still a lot more to do. If we look at the ozone layer in mid-latitudes, as they're called, where all the people are, so this is also really important, the quantity of ozone was never as high in the mid-latitudes, and it did not dip as low as it did in the Antarctic and actually also in the Arctic. But it's also on that recovery trajectory, and perhaps by 2040 or 2050, we'll be back to the levels that we had in the 1960s. That's a very, very slow healing process, and we're only partway there. What I'd like you to do is focus in on the beginning of this graph, 1960 to 1980, because the level in 1960 was 350 Dobson units. And one of the things that we should be celebrating in this year, 2024, is this is the 50th anniversary of the publication of the Rowland and Molina paper, which pointed to the Antarctic ozone layer and said, we have a problem. It took 12 years for the Montreal Protocol to be produced on the basis of that scientific evidence and more. 12 years is really a very short time, and it took another 3 years for the protocol to be ratified and entered into force in 1989, and it's now one of the most successful treaties in the world, international treaties, recognized by all 194 member countries of the United Nations, plus the Vatican. So this is good news. We have the Pope on our side as well. This is excellent. Plus the European Union. So really universally acknowledged as being the way forward, part of the journey. But in 1974, when Roland and Molina published their paper, the Dobson unit measure in the Antarctic had only dropped by about 7%. There was a 7% shift, and they said, scrolling forward from here, predicting the future, we will have a massive problem if we don't act soon. And the world responded to that cry for action, and you can see the evidence here. We are on that return journey. So I would say that the restoration of the ozone layer is a massive success story, and particularly at this 50th anniversary, well worth celebrating, partly because significant action was taken on the basis of very tentative evidence. Moving to carbon emissions and climate change and so on, maybe not such a fantastic story to tell here. I want to talk about surface sea temperature here. There are lots of measures that we can use for is climate change a real thing? And over the last 40 years, part of the difficulty that we've suffered is a lot of people saying, it's all nonsense, don't believe it, it's not true, it's just a conspiracy theory. And I used to look at Arctic ice as my metric to say, is something changing or not? Because the extent of Arctic ice has changed dramatically in the last 40 years. And some people would say, well, that's just a natural cycle, it's coming back again. There's no concern, there's no problem. But more recently, I've been looking at the measure of surface sea temperature around the globe. And these are temperatures that are taken between the two red lines that you can see in the graph. That's between 60 degrees north and 60 degrees south. And as I said earlier, that's where all the people are. So really, it's quite important. And if the measures are taken by satellite, and they're on a grid that is 0.25 degrees of latitude by 0.25 degrees of longitude, and that gives you, at the equator, a square of about 28 kilometers. So these are measures taken every 28 kilometers in all directions around the globe, and they're aggregated and correlated. In August last year, 2023, the BBC published a graph of these measures, and you can see the graph here. And it was published on the 4th of August last year, and the reason they published it was because the surface sea temperature aggregation, the average of all of these readings from all around the world, had hit a new record high. They said 20.96 degrees C. As I was preparing for this talk, I thought, well, that was a year ago. What's happened since then? So I looked back and I found the source data that was used by the BBC to draw this graph. And I plotted what had happened since then. And you can see the kind of dark red line continues the trend for 2023. The orange line is the data for 2024. And you can see right up until July this year, the levels were higher than ever measured before, averaged right round the world between 60 degrees north and 60 degrees south. Now, you might not be able to see the grey lines terribly clearly. The grey lines are every year since 1979. But as an engineer, I like working with numbers. I like the data. So I plotted the average for the first 32 years of this 40-year history. And you can see the average over 30 years was down at the bottom. And then being an engineer and liking numbers, I plotted the two standard deviations around that average over 32 years. And you can see the two standard deviations here. Something significant has happened in the last 15 years compared to the previous 32 years. So, as an engineer, these numbers really shocked me, and I hope they shock you too, because it is really a substantial change. I liken it to if you're driving your car and it starts to make a little bit of a kind of whining noise, you might be upset by that. You might think, I really ought to take it to the workshop and have a mechanic check it out to find out what this unusual behavior is, this whirring noise. But after a few kilometers, maybe a few days or weeks, you get used to the noise and you think, well, it's always done that, it's okay. If it starts making a really loud banging noise, that really makes you sit up and pay attention. In August last year, the surface sea temperature started to make a really loud banging noise. When we look back into the data, we find it had been making a whirring noise for the previous 15 years and we'd been ignoring it. Are we still going to ignore this loud banging noise that the surface sea temperatures are making, or are we going to do something about it? So, moving on, I would say there are strong arguments on both sides. So we look at this surface sea temperature. I find it very disturbing. I find it very compelling. But some people would say, for example, CO2 levels have been much higher in the past. This is true. They might say climate change is following a natural cycle, and the natural cycle predates industrialization. This is also somewhat true. They might say previous CO2 levels always followed increases in temperature. The increase in temperature came first, and then the CO2 levels rose afterwards. You might remember Al Gore, An Inconvenient Truth, the hockey stick. This was the big criticism of Al Gore, was people said, but the temperature rise came first. And they might say humans have already adapted to warmer temperatures, so what's the fuss about? Do we need to worry about this? It's actually, everything is okay. So I want to show you a couple of graphs. This first one looks back over the last 150 million years. And this shows the global average temperature, not just the sea surface temperature, but the temperature all around the globe. Now, they didn't have satellites 150 million years ago, so I'm not entirely sure the pedigree of the data, but let's take it as read as appropriate. And you can see, for example, 65 million years ago, there is a sudden spike down. This is the asteroid strike that killed off the dinosaurs 65 million years ago. Prior to that, the temperature was up round about 28 degrees C, and the global average temperature at the moment is round about 14 degrees C. So it's absolutely true to say global temperatures have been much higher. If you look right in the bottom corner of this graph, you can see there is a kind of grey fuzz. It's not an accurate representation of the temperatures in that recent period. It's just the artist's impression, because if we zoom in on the last 50,000 years, you can see, as I mentioned earlier, yes, the global temperatures have been cycling up and down. This graph shows the blue is the temperature and the red is the CO2 level. And if you were to look really closely, you can see, yes, indeed, historically, the blue curve, the temperature went up before the CO2 levels. So you could say, well, logically, the increase in CO2 levels is a consequence of the rise in temperature rather than a cause of the rise in temperature. However, there are a few things that I would observe about this graph. The first is that the rate of increase in atmospheric CO2 and the rate of increase of sea surface temperature is new. It's never happened at that speed before. It took about 10,000 years for the CO2 level to rise by 100 parts per million, and it's risen by the same amount within the last 75 years. And worse than that, it started 75 years ago at the top of that natural cycle, not at the bottom. So something is definitely different to the history that's happened many years before. And if we focus again, zoom in on this, the most recent part of the graph is actually inaccurate because the CO2 levels now are literally off the chart. The current level of CO2, about 430 parts per million, is up here. So you can see that increase in the last 75 years has taken us from the peak of the CO2 levels and just about doubled the level from there. In addition to that, I would also observe, I mentioned 8 billion people in the world. We've never seen this rate of change or this level of CO2 when there have been 8 billion people observing. We're in the spectator seats. We can follow what's happening, just like being at the tennis. You know, you see everything that's going on. never been witnessed by 8 billion people before in the entire history of the world. And furthermore, as Alex mentioned already, we're the only species on the planet that can do something about it. It doesn't matter whether we caused it or not. We can't leave it to the penguins to fix it. We can't leave it to the polar bears. It's up to us if we choose to do something about it, for better or for worse. We could choose to do things that actually aggravate the situation and make it even worse. And finally, I would say, if our systems become safer and more efficient because we've taken action in response to this rather shocking information, but it turns out not to be necessary, is that a bad thing? Is it bad to have a more efficient system, a more reliable system, a safer system? I would say no. I think it's worth investing the effort. And if this happens to be the incentive that gives us the call to action, I'm in favor of that. So I want to talk a little bit about what's coming next, because we look at the last 40, 50 years and we can see various behaviors that happened last time around and the same thing coming along again. Great success with ozone, not so much with climate change so far. So I want to talk about changes to the electricity supply. And this might seem like a bit of a diversion for a talk about refrigeration, but I'll bring it back around again. You'll see where I'm coming from. So if we talk about the grid carbon intensity, this is the journey that we're on. On one end of the scale, we have 1,000 grams of CO2 per kilowatt hour generated. And at the other end, the destination, if you like, 0 grams, net zero carbon. So that's the journey. The graph is back to front if you think of it as a graph, because the high values are on the left-hand side and the low values on the right-hand side. We can put another axis here and we can talk about the extent to which we succeed in electrification. You know, we're transferring from using petrol or diesel in combustion engines to electric vehicles. We're transferring from burning coal or gas for heating to using electric heating or heat pumps. This is electrification. But the key thing about these two activities, they're independent, but we have to succeed at both of them. We have to be good at multitasking, basically. And, you know, I'm not very good at multitasking, so this is a bit of a challenge. And just to put a bit of color on the graph, if you think that red is a bad result and green is a good result, we have to succeed at both decarbonization and electrification if we're to have a successful result. So this grid carbon intensity reduction, we're doing that, for example, by moving from burning coal to burning gas, and moving from burning gas to burning wind, if you want to think of it in those terms. So that gives us that transition along the axis. And if we think about electrification, I mentioned we're moving from fossil fuel vehicles to electric vehicles. In the heating world, we're moving from burning things to maybe electric heating, or even a more intelligent use of electricity in a heat pump system. But does any of this activity on its own get us up into that top right-hand corner, into that green zone, which is what we're aiming for? And I would argue, you know, from a refrigeration engineer point of view, I can't do a great deal about the grid carbon factor. We just have to use the electricity that is available to us. But I can make a difference in the electrification axis. So there are things that refrigeration engineers can do to improve this situation. So we're aiming for the green zone. Just bear that in mind. I want to talk a little bit about the situation in Serbia, just some statistics that I pulled from surfing the web. Last year, Serbia generated about 36 terawatt hours of electricity, and the grid carbon factor was around about 500. You're almost exactly halfway along that journey from 1,000 to 0. And the reason for that number, I'm not saying that's a good number or a bad number, just that is the fact for the grid in Serbia. 59% of the generation was from coal, and that produced 96% of the carbon emissions for the country. That's not a great statistic. The world has been moving away from coal-fired, but it's difficult because coal is cheap, it's available, and it gives a very reliable grid system. So it's difficult, genuinely difficult, to move off coal. It's not a simple thing as is sometimes presented in the press. This is one of the highest grid emission factors in Europe. I stopped looking, but I didn't find many that were much above 500. So, you know, there's a lot to do, and I'll talk a little bit about that in a moment. But on the other side, 33% of that generation was wind-fired. This was from, 33% was water-fired. It was from hydro plants, and a small percentage, 2%, from wind farms, but that's a growing percentage. So there are signs of encouragement in that scenario, but it is necessary to carry on that journey. Now, if I compare with the UK moved off coal-fired generation in the 1980s. This was not really to do with any environmental credentials. This was Margaret Thatcher bashing the miners, basically. She had a political agenda, and that moved us into what was called the dash for gas, which was shifting to gas-fired power. And as a result, our grid emission factor is about 200 grams of CO2 per kilowatt hour. But we're stuck. We've hit a barrier, and it's not reducing further. In 2023, about 40% of our generation in the UK was from renewables. About 30% was wind, 5% was solar, there was a portion that was biogas, there was a portion that was hydro, so about 40%. And we're increasing the amount of renewables all the time, but our grid emission factor is not dropping much below 200 grams CO2 per kilowatt hour. We've hit a barrier. And Serbia will hit a barrier as well. I don't know if that's at 450 or 400 or like the UK at 200 or maybe even lower, but there's a point beyond which it is exceptionally difficult to reach. In the UK, our average consumption would be about 30 gigawatts at any time, and a peak, the absolute maximum, about 50. Because of electrification, because of the y-axis in the chart that I showed, we are increasing that demand. But we're predicting that by 2035, we will have a total of 195 gigawatts of available capacity for renewables. Now, there's no way that we need 195 gigawatts at any one time, even by 2035, even with electrification. And the problem that we face is because the average is 30, the peak is 50, sometimes we have massive overcapacity and we have to curtail the generation. And if you're curtailing the generation, there's no point in installing more capacity, because if the sun's not shining because it's midnight, or the wind's not blowing because it's a calm day, then having double the number of wind turbines or solar panels doesn't make any difference. The problem that we face is the intermittency. So does this get us into the green zone? No, not quite. We're kind of stuck on the border between red and yellow at the moment, and we're struggling to get further. So we've reached a barrier, and I think Serbia will get to their barrier quite soon. And it's about figuring out how we get beyond the barrier. We need a reliable way to cope with unreliability. And there's a huge amount of research going on. It's another reason why it's a good time to be an engineer just now. There's a lot of work being done in solving this problem of making the unreliable into something reliable, dealing with the intermittency. This hasn't been concluded. There are lots of technologies under development, and it's not a case of there being one winner and lots of losers. There will be lots of appropriate solutions to find. There are some really bad ideas being proposed as well. It's not that everything is awesome. There are some dreadful ideas being proposed, but equally there are lots of gemstones in amongst that, so there's lots of good things to search for. Still no clear winner in that regard. This will also radically this is where we come kind of back around to refrigeration again. This will radically change the way that we buy electricity, and that's already happening in some sectors. So you can expect to see much wider variations in early tariffs. You can see minimal advance notification. I mean, this is all about predicting what the weather's going to be doing shortly, and actually the forecasters are pretty good at that. But when the price of electricity is based on that, it becomes quite a difficult situation. So you'll get as much notice as the weather forecasters can advise, but that might be your tariff is going to shoot up in the next half an hour or the next 2 hours or the next 4 hours. So the way that we control our plant needs to flex to cope with that variation. And it won't be an optional thing that we can add to the system. Electricity will just be packaged and sold in this way. So I want to move on and talk a little bit about changes to the refrigerant supply. We talked about changes to the electricity supply. I first produced this graph in 1999, and I've updated it several times since then. The red box is illustrating a key point, which is that in the early years, the first 50 years of mechanical vapor compression refrigeration, which I would say from 1834 to 1884, there was a huge wave of creativity, 8 new ideas, roughly a new idea every 5 years or so, a new concept in refrigeration. And then from 1884 to 1984, 100 years, double the length of time, only one new idea. Thomas Midgley in the 1920s, 1930s, with the introduction of firstly CFCs and then HCFCs. So huge creativity at the beginning, very little happening from that perspective for 100 years, and then a wave of creativity again more recently. Ammonia is the only refrigerant that's been in constant, widespread use since it was first introduced in the 1860s, and it's continued to be in use throughout that time. So it's quite special. And there are lots of good reasons for that we'll not go into today, but just bear that thought in mind. It was there 150 years ago, and my chart predicts that it will be there in 50 years' time. Again, I want you to focus in, and this is again touching on something that Alex has already mentioned in his presentation. This is a personal view. Don't take it as the gospel truth. If you disagree, come and have an argument with me afterwards. But my prediction is that HFOs will be phased out before HFCs are phased out. And just hold that thought in your minds while we think a little bit about how that will change the refrigerant supply. I want to talk a little bit more about PFAS, which Alex mentioned briefly. What is a PFAS? As Alex said, there are millions of them. 6.5 million, I think, was the number that you said. I've not counted them, so I'll take that. I'll take your word for that, okay? But it's defined as something which has a carbon backbone, so that means at least 2 carbon molecules. And on that backbone, either one of the middle molecules has got 2 fluorines attached to it, or else one of the end molecules has got 3 fluorines attached to it. That is what we mean by a polyfluorinated alkyl substance, a PFAS. And lots of things are PFAS. So a few of the refrigerants that are classed under this definition, which is the European Chemical Agency's definition, R134A is a PFAS, 1234YF is a PFAS, 1234ZE is a PFAS, 143 is a PFAS. Interestingly, there are some things that are not PFAS. R152A, not a PFAS because it only has 2 fluorines and they're both on one end of the molecule, so it fails the 3 fluorines on the end. It's not a PFAS. R32, not a PFAS because it only has 1 carbon molecule. There is no backbone. So according again to the ECHA definition, not a PFAS. Now these are interesting because they're both punted as being lower GWP solutions to some of the higher GWP refrigerants that we've used in the past. R32 used to be called about 675 100-year GWP. In the most recent AR6, it's actually up about 770, possibly because there's more of it in the atmosphere now. 152A was the archetype less than 150. Alex mentioned 150 being one of the thresholds. So R152A in, I think, the second assessment report was classed as 140 and therefore limboed under the bar, just and no more. But these are not PFAS. So if a regulation comes about refrigerant substances that are PFAS, will they be included or will they not be included? This is an important question to bear in mind. Interesting thing about PFAS is the atmospheric life of the refrigerant. R12 is what Thomas Midgley developed in the 1920s, almost 100 years ago, and you can see atmospheric life of 140 years. So Thomas Midgley did a famous experiment. He breathed in a lungful of R12 to prove that it was non-toxic, and then he gently puffed his breath over a candle, and the candle went out to prove that R12 was non-flammable. So he ticked the non-toxic, non-flammable box with one very, very graphic demonstration. But what I would like you to think about today is that breath from Thomas Midgley, that R12, is still in the atmosphere. Whereas the stuff that leaked out of your car 2 weeks ago has gone already because the atmospheric life of 1234YF is only 11 days. So it's breaking down much, much more rapidly, and we're getting to the end point of that chemical process much, much faster than we used to. And that is very, very significant when we think about F-gases and the environment, because it's a radical change to what is actually going on in the chemistry of the situation. So I mentioned 152A and R32, not PFAS. Both of them, as you can see, well, R32, about 5 years atmospheric life. And again, the question is, what do they break down to? Well, with these 4 PFASs that I've listed here, 2 of them, R134A and 1234YF, will produce the trifluoroacetic acid that Alex mentioned. The other 2, 1234ZE, E, Entgegen, and Z, or Z as the Americans say, Zusammen, these do not break down to TFA. So again, there is a possibility that we will have a PFAS regulation, but it will include R32, but it will not include 1234ZE, either E or Z, because although they are PFAS, they don't break down into the what are called the persistent organic pollutants or forever chemicals. So this requires a very nuanced approach from the politicians. And one thing I've learned from the last 40 years is they like a single number metric. They liked ozone depletion potential, and then they liked global warming potential. We tried to introduce total equivalent warming impact, not fantastically successful. Life cycle climate performance. It was all about giving the politicians a single number to aim at. We're now talking about something that is much, much more complicated than that. So my expectations are not high. Again, a personal view, but I don't trust the people making the laws to make a really appropriate, sensible law. Maybe they will, maybe I'm wrong, who knows? But it's complicated is the underlying message. So if not PFAS, then what? Well, there's one word answer to that question, and that answer is training. It's absolutely essential that we learn to do things differently. This goes for the youngsters coming out of school and beginning to learn their trade, but it also goes for the guys that have been around for decades, that already know everything and they know what they're doing. And the reason is we're going to have to move, and it's already happening to an extent, as Alex mentioned, we're going to have to move to using CO2, to using hydrocarbons, to using ammonia. And I want to focus for a moment on CO2 and hydrocarbons because there's an interesting twist here. If you look at a CO2 machine compared to an R134A machine, it looks really quite radically different. You know, things are much beefier, the pressures are higher, and the components need to be stronger. And it looks quite different, but actually as a mechanic, if you treat it in much the same way as an HFC system, generally you'll get on okay. With hydrocarbon, the system looks really familiar. It looks exactly the same, but if you treat it the same way, you will find yourself in massive problems. So the training is about teaching people that when it looks the same, you have to behave different, and when it looks different, maybe it's okay to behave the same. And that is not an easy message to land, especially with people who believe that they know it all already. It's the older guys that we're going to struggle to retrain, in my opinion. Again, personal opinion, you can choose, especially if you're an older guy like me, you can choose to disagree with me if you want to. But this is why training is so significant. So let's look forward a little bit to 20 years from now. What do I think the landscape will be? Well, firstly, I think electricity will be sourced pretty much predominantly from renewables because we will have addressed that reliability from unreliable sources question that I mentioned. We'll see both short, medium, and long-term answers to the intermittency question, and more users will be transitioned onto the electrical grid, so we will have made significant progress in that electrification y-axis of the chart as well. So there is really strong positive suggestion that we will be making it to the green zone of that graph. Refrigerant control will have to be much more flexible to deal with the supply of electricity, so there's a big lesson to be learned for the controls people. And it will be predominantly ammonia, CO2, and propane by that time, by 20 years from now. I've not talked a lot about this, but I think there will be a massive growth in the cold chain serving large cities. Global population is still increasing, and a lot of that is urban population, especially in Africa. The urban population of Africa will increase by 1 billion people over the next 25 years or so, and they all need cold chain to feed them. It's not subsistence farming. I think for technicians that will mean better training, will be absolutely essential, and I hope that that will lead to better salaries for the technicians because they're better trained. And if you're a contractor like me, you might be thinking, this sounds like bad news, I'm going to have to pay my guys more. But you're providing better qualified people, so I think it will mean better profits for the contractors as well. So good news to come at the end of the presentation. So I'll give you a few conclusions. Might surprise you. First conclusion, this is not the conclusion. We're on a journey, it's a progression. So we won't have got there in 20 years' time. We need to find new ways of working, new ways of buying energy, new standards of efficiency, safety, and reliability if we want to move forward. And just a conclusion from the written version of the paper, we need to start behaving more like entrepreneurs and innovators and running towards the challenges rather than trying to duck and avoid them. We cannot hope that somebody else will solve these problems for us. It's on us to do something about it. So I thank you for your attention. I'm very, very happy to chat afterwards or exchange views, and I hope we'll get a good conversation going. Thank you very much.
Thank you, Andy. Thank you very much.
Thank you.
Thank you. The next, our distinguished lecturer, Pavel Vargocki, sa radom Zdrave zgrade, 50 godina kasnije, dok smo stigli. Mr. Pavel, the floor is yours. Thank you.
Oh, sweet earth, yeah. Well, please stay in the room. It will be a very exciting presentation. Well, thank you. I hope, at least. Okay, someone has to inform me about the time, but okay. So, first of all, I would really like to congratulate the Congress and Professor Branko Todorovic, Blagojevich. I'm coming from Technical University of Denmark, which was always a great friend of this Congress. Professor Fanga, who was my supervisor and then collaborator for many, many years, was coming here and was a friend of Professor Branko Todorovic. So all the best because of the of this wonderful anniversary of 55th Congress. I'm here for the second time, actually third time once when I was online. And I have two news for you and two disappointments. First of all, I cannot speak Serbian. Well, I can try Polish, maybe you can follow. And then the second is that I will not speak about the cooling and refrigeration. So, but please stay with me. So I'll speak about something else that Professor Katalin Lungu mentioned to us. Why are we not proud of having the systems in the buildings that provide the buildings to be healthy? We are proud of everything, but not proud of something that is actually crucial to all of us, this environment in a building. All the systems, technical systems that we develop that have impact on the environment, they have impact on us. So if we are creating environments which do not support our life, all those systems become obsolete, because why should we do them? Why should we install them if they do not serve the purpose? So I'll try to convince you that this is the case and talk a little bit about the healthy buildings. And here. And what is the healthy building, and where we are today, and what are the challenges for the future, and so on and so on. Again, I'll not speak about cooling, or very little to that. But first, reflection. So probably this is something trivial to all of you, but something that we really need to think about. Our habitat are buildings today. So if we take an average lifetime of a male in EU, which is 79 years, of those 79 years, 69 years we will spend in buildings. This is where we live today. We are not living on the outside. Outside we live only 6 years during our lifetime. And the rest 4 years of the 10 years that is missing in this equation is we commute. So we are also inside. And then mind that 54 years we are at homes. So home is actually mainly our habitat and the bedroom, where we spend 1/3 of our lifetime in our bedroom. So current habitat of people are buildings. And in the buildings, we breathe the air. We breathe the air that is coming from outside and inside. And if we think about how much we breathe every day, you would be surprised. We breathe about 11,000 liters of air every day. Now compare it with the 2-3 liters of water that we have to drink. So air is extremely important pathway by which we get pollutants in the building. This is not the only parameter that we have to think, but just to give you this understanding of how important it is to us. And of course, buildings are extremely important because they produce the important impact on our climate. And of course, these numbers, you all know those numbers. And please note, buildings actually generate more than transport and industry. So this is where we have to focus. And of course, with renewable energy use and so on and so on, we will be reducing the impact, this impact that is shown here. But then we will be talking about embodied CO2, which is also a very important part of that. So all the retrofit and renovation strategies that we will be thinking about have to take into account the life cycle cost analysis of how much CO2 is embodied and how much time has to be passed in order to basically balance it out. So that is another challenge that has to be taken. So then we talk about the smart and green buildings. So smart and green buildings often are referred to the buildings that use low energy or have a very low emission of CO2. But I would say that the buildings to be called smart have to have two major characteristics. One is, of course, reduced impact on the environment. And the second one is, of course, creating an environment that is healthy for people. So they have to be climate neutral and not create the health for people, risk for health for people. They have to follow the sustainability definition. Often in the sustainability definition, we forget about important part, which is we think about that the sustainable development is just to reduce the impact of the environment. But actually, sustainable development is the meeting the needs of the present without compromising the ability of future generations to meet their own needs, which means the future generations have also to live and do not have a risk for their health and thrive healthy life in the future. So our goal is all buildings should be healthy, all, without no any. Today, probably many of the high-ranked big companies, rich companies, their buildings are healthy, but there is a huge, massive part that requires improvement. So now the question would be why we need a healthy buildings. So let me put it in a little bit unorthodox approach in which we just think about a healthy building as a part of the entire decarbonization process. So let me put this, stipulate that this is a part of the decarbonization process. And achieving healthy buildings will, in the end, reduce the CO2 emission and impact on the climate change and environment. Often, healthy building is equated with, okay, we need to use more energy, there is more embodied CO2, and so on and so on. So actually, we have to figure out how to balance it out with all those aspects and impacts. So I believe that healthy buildings can actually be a part of the decarbonization thinking. Why? So, let's think about the healthcare. 4.4% of all global net emissions of carbon are actually generated by the healthcare. And this is some examples. So, if we think about holistic approach to life cycle cost analysis in a building, so of course, the indoor climate will have an energy impact, the impact on how we work and our health impact. So they will generate embedded carbon, operational carbon, economic benefits. By having healthy buildings, actually, we can reduce the healthcare burden, which I remind you is 4.4% of all the CO2 emissions. And then we can reduce carbon. So having people healthy in the buildings will actually contribute to reduce of the carbon emission. And this is just an example of the of how much this cost to the global emissions of CO2 when we have different health aspects. So we can actually, by providing healthy buildings, reduce those impacts on our emissions of CO2. So now to the meritum. So what is the healthy buildings? Well, 50 years ago, actually in '88, when it was coined, the healthy buildings was called that should not compromise the basic human requirements, which include high quality of life, good health, and optimal physical and mental activity. I think today we have to think about that the building should not compromise the basic human requirements of every building occupant, every. So this is one part that has to be considered. The second one is it should foster a high quality of life. So we should not only think about the buildings that reduce the risks, but also create conditions that support our health. It will be similar to the fact that, for example, we go and buy the water or some special food that would strengthen our health, our resistance against certain diseases, and will extend our life. Why don't we think about a building that extends our life by a few years rather than reducing the risk of building, reducing our life by a few years? So this is the thing that we need to consider in a healthy building. And also, I think, except for the physical and mental activity, we should start thinking about our sleep quality. And I'll come back to this. And I had a presentation last year here about this. So the healthy buildings should be resilient. And this is and I'll come back to this in a moment, this is the biggest challenge today. In the past, we could design the buildings based on the more or less constant climate conditions and avoiding large events, except maybe for the earthquakes and strong winds and so on. We didn't have to take into account changing climate. We just saw what happens from Andy's presentation. It's just like, you know, the temperatures are changing from year to year. So how we address the time of the elevated temperatures, overheating is occurring over extended periods. How we make our buildings resilient and responsive to these events. Then they should be flexible and inclusive that they should be for any one of us. I have that preference, someone else has different preference. So how do we make sure that all our preferences in a building are met? I think the most important is that all our buildings do not create a similar or reduce by the same amount the risk for health. So it is not that I go to one building that is more healthy and the other building that's less healthy. All the buildings should create the same level of protection against the health risks. And then they should be adaptive. Adaptive in a sense that meeting the needs of all the people in a building. And finally, as I said, is to the buildings that will promote health. There is a one word that probably becomes a new sort of the buzzword that we will be talking about. Is called salutogenesis. It's basically to creating the environment that actually promote health. So because today we create buildings based on the pathogenetic approach, meaning reducing the risks. So buildings that create positive sensation, fulfilling all preferences and enhancing our health. Think about a building that will enhance our resilience against infection disease. Well, that maybe sounds like a utopia, but I think we have to go beyond our traditional thinking and go and try to create something that will really be in the future, will serve our future generations. I'm checking, okay. So what are the main elements of a healthy buildings? We know that the main elements of a healthy buildings are the thermal environment, air quality, light, visual, and acoustic environment. That we know, and these are the traditional components that we know, and we can control them. To some extent, we understand them, we know how to design them, we don't know how to combine them, and we know that they are affecting us. I think the other two parts that have not been considered very much is one is a contact with nature, which is one of the salutogenetic approaches, which is the biophilic design. And we see this coming into buildings, and we don't have to think about it like biophilic design. Having plants in a building will improve our quality. Actually, it will reduce our stress, and in this way, it may have an effect of our overall perception of the environment, and of course, our behavior. Sometimes in the buildings, we forget that there are people, and then the people have certain customs, and we can behave differently. An example is the low energy buildings, which use much more than actually in that was the energy that it was designed. Because people behave in those buildings, behave according to the conditions in the buildings. So they know that a building is low energy, the temperatures can be increased, so they change, their clothing, and they actually use more energy that the buildings actually was designed to use. Of course, still less than a traditional building, which is not low energy building, but still, this performance gap is attributable to a large extent to our behavior that we need to take into design and think about it, how we can address that. That applies also to the healthy building. The building in which people open the window or do not close the window and do many other things which we may consider as engineers stupid things, but this is natural, it's in our nature. So there are documented effects that all those parameters, those components affect major parameters defining our health. They affect our well-being, they affect our comfort, they affect our sleep, and also they affect how we work, how we learn, how our children, the students at the university learn. So it's extremely important that we need to take this into account. It cannot be avoided. They are there and they have to meet the optimal requirements. Healthy buildings are also economically viable. I just give two examples. You probably know about this, but it's just give you two examples. One is that according to the estimates, about 2 million healthy life years are lost because of a poor indoor air quality in buildings. Think about 2 million healthy life years in Europe. And exposure is in buildings where there is no tobacco smoking occurring, and where half of the pollutants are coming actually from outside, which are not cleaned before they come in. That costs about 200 billion euro annually. 200 billion that can be invested in the systems that can support people living in those buildings. And then this is comparable, for example, to the loss is comparable to the traffic, road engineers, and we, of course, have a lot of investment in road traffic, but why not investment in the building from the health point of view? And then it's comparable with the GDP of Cyprus. I don't want to talk about COVID and how much it costed. We all know about this. And then we also know that the indoor environment affects our work, sleep quality, and also affects our learning. And I will quickly show it. There are systematic data from different parts of the world, not only from our lab, that show that there is a clear relation of this. And this clear relation can be transferred into the economic implications. If we think about a building in the developed part of the world, and Serbia is becoming a developed country, more and more, there's 90% of the cost, or maybe in Serbia 80 or maybe 70% of the cost are people in a building. Energy and rent is only a part of that. So if you think about how much you can actually save by providing a good, healthy environment in a building, usually the payback times for investments in a healthy building are much, much shorter than in any other technical investments. And also too short sleep. This is what we all experience today because of a stress and living and so on, and using too much maybe smartphones before we go to bed. But nevertheless, there is also an element in which we can improve. Okay. So what are the future of the healthy buildings? Andy was talking about this, so I don't want to talk about it so much. We have a challenge. There are significant changes over the last decade, and actually over the last 3-4 years that are happening. And they need to be addressed in the buildings. And these are, changes occur outside, for which we have very little influence, and also inside because of the change in the mindset of how we should work and live and so on. I just want to tell you that there is a new generation growing, a so-called Gen Z, which actually think completely differently than we think. And then they will require a lot of change in a building to fulfill their preferences and requirements. And then there are several there are several challenges for our buildings. And one of them is climate change, the change of a building stock, which is decarbonizing, and then how this is affecting us. New man-made pollutants, and so on. I want to flash a few of those, and then I will quickly, sorry, I cannot go back. I just quickly, because I know that the time is running. And so the first question is, can we design healthy buildings? I believe we can. We have evidence today. Maybe it's crude and not complete. Nevertheless, we know how to design a building that is healthy. We know. We can always improve. When Steve Jobs developed the first iPhone 3, he was not dreaming of an iPhone 16. He was dreaming of an iPhone 3. And then he learned from iPhone 3 that we need to do something to go to iPhone 4, then to go to iPhone 5, and so on. Why? Because he monitored how people use the iPhones. And sorry that I said about iPhones. I can say also about Samsung, Xiaomi, and all the others also like this. They do the same. Monitoring is an essence. We do not systematically monitor buildings, environment in buildings. We have labels for energy, we have labels for outdoor environment, and so on. We don't have monitoring for buildings. And this monitoring is important for several reasons that I list here. One reason is to tell you whether you are safe in this building. The second reason is to have control systems to operate properly. And third is to make an improvement. So there are some examples of how we can monitor buildings, and there are some developments that I show here. This presentation will be available to you afterwards, so please. And then, so this is, we have to start doing it on a regular basis. The second point is resiliency, building design and operation. I mentioned this, and those resilience should relate to overheating, infection control, wildfires, ambient air pollution, and any other unexpected event. Of course, infection control is probably the biggest challenge today. The buildings that we create are not infection resilient, to be honest. And we have to do something about this also in terms of legislation. One example is ASHRAE 241 standard, control of infectious aerosols, the first ever infection control standard for the buildings. But also there are many other methods that need to be implemented. Overheating, a huge issue. Maybe not an issue for Denmark, to be honest. The temperature will slightly increase. We will have probably a week longer overheating period, but maybe problem for Belgrade. And if we go south, even bigger problem. So it is a problem, and north, not many people living then, and here much bigger population. Huge problem because, among others, cumulative days of hot days. So some people say, okay, this is not an issue because the temperature will only increase by 0.5 degree or 0.2 degrees a year, average on the globe. But we will have a long overheating periods and many other weather events that we don't want to have. So overheating is affecting learning. We have to remember that the new generation is growing, and if they do not learn properly, probably artificial intelligence take over them, because they will not learn that well. And then also temperature affects sleep. I'll have to quickly drop here. Air pollution, I'll have to also drop. I was preparing for this, I'm so sorry. So, because there are many other challenges, and I'm terribly sorry that I had to skip over some of the slides, which actually show that we need to find new solutions for the buildings, not only by the technical solutions that we have to develop, and also that we have to think about how much we sleep and how the environment affects our sleep. I think this is a huge issue that we need to think about, and we need to also think about outdoor environment. And generally, we need to think about air. Air, like water, is a public good. So we building engineers cannot be responsible for the fact that outdoor air is polluted. We need to actually exert the pressure on the other legislators to actually regulate outdoor air, because we cannot, it costs energy to clean the air that is not clean outside. So the epilogue, what should be done in the future? So we have a high level of ambition which is necessary. Today the buildings follow the standards that basically are crude codes and standards. We are over-dependent on the existing crude technological solutions. So I think that even our cars are today better equipped with the systems than our buildings, to be honest. And then, I'm sorry, I'm saying things just to maybe exaggerating them, but trying to point out to the point that we need to probably make a change in the mindset. And we do not address combined effects of all the indoor environmental parameters. And all of that is actually a factor that limits our innovation and development. So going for the high ambition actually will increase our innovation and development. So take out home messages: healthy buildings secure basic human requirements of every building occupant and foster high quality of life, good health, optimal physical and mental activity, and sleep quality. All buildings must be healthy. This is a part of sustainability concept and actually a contributor to the decarbonization. And healthy buildings are crucial in efforts of achieving in efforts achieving to secure public health and sustainability. And this is the framework for the future healthy building that is depicted and published in a paper recently published in a Building and Environment, in which actually the buildings, healthy buildings, are thought as designed for human needs, sustainably managed and built. We have to think about that. Sustainability is not only at the design, also when the building is operated, and we also lack of that properly resilient and adaptive, and empowering people, and improving mental and physical health. Mental health is extremely important. Today we see a lot of problems, and then it seems like it will affect our physical health. So I'd really like to thank you for attention, and I'm sorry, I'm right on time, 30 minutes, so thank you.
Thank you, Pavel, thank you very much. Sada I'll ask our next and distinguished lecturer, Oddgeir Gudmundsson. Njegovo predavanje instalacija hlađenja u sistemima daljinskog integracija hlađenja, u sisteme daljinskog grejanja. Izvolite. Okay, the floor is yours.
Thank you.
Thank you.
So, I want to discuss a little bit with you about comfort cooling. It fits directly to you, I guess. And then in the synergy with the district heating systems, because I think that is very important to take that into account, that when we fulfill growing cooling demands, we have to do it so we can do it sustainably. I have been in the company Danfoss since 2012, and I have worked there as a district energy expert, just so that you know a little bit about me. And my activities, they are all over the place, but always around district energy systems. I'm actively engaging in various international projects and communities. I support universities when they have some thoughts about district heating or want to do projects or whatever their interest is. I advocate quite strongly for district energy systems, and then particularly in perspective of the wider energy system, because this is an infrastructure to couple together the different aspects of the energy sector. Then I also go into the components that we are producing in Danfoss, and I analyze them and see how they might fit into the energy system and the impact they will have, as well as developing new applications. A core part of my activities is also to share knowledge, which is why I'm here, for example. So I have a PhD in engineering from the University of Iceland. I live in Denmark, like the two other speakers in this panel. And then there's one from Scotland, I guess. Yes. So this is a very famous graph of district heating development, and I will not say much about it, but the key themes, they are about secure and resilient supply, using more and more local renewable energy sources, and sector coupling. That has been the driver for the development of this technology for 100 years. But we see some new emerging themes, and there it's particularly comfort cooling, because district heating, it is for heating purposes. But if we want it to succeed in the future, we also have to make sure that we can somehow accommodate cooling demands. Because if we don't do it, then the risk is that building owners, they will install their own heat pumps, and if they have their own heat pumps, they might start simply running them for heating purposes as well, and we will deteriorate the business potential for the district heating systems. But if we start accommodating comfort cooling demands, then we also change the whole business model of district heating, because in some aspects it means that we are creating an open access system. And that is a huge difference compared to what the normal operation of district heating system is, where we have one utility which maybe has one source supplying the system or operates its own multiple sources. So this will be a huge driver for the future development of this technology. But we are also seeing that district heating is becoming more and more popular. We are noticing that EU recognizes it as a good way to decarbonize the heat supply. And it really is, because we can tap into sources wherever they are, which we could not be doing on a building by building level. And this is also driven a little bit by the Scandinavian countries, because they have been extremely successful in decarbonizing the heat supply through the district heating system, and as well driving the development of the technology. And this has particularly been through this fourth generation of district heating, or low temperature district heating. And now we have probably tapped the potential in the Scandinavia, and we are seeing systems being developed more and more south in Europe. But there we have a little bit of a challenge, because if it's cold, then district heating is a perfect solution. But when it gets warmer and warmer, then it becomes a little bit different, because yes, we have heating demands, but we have increasing cooling demands. And while I'm from Iceland, in the top corner, you will see that we don't have cooling demands. We just stay cool. But if we go to the south, and I say, if we want to have district heating, we need to have cooling in mind. And it's not only that we have warmer climates, we also have a changing demography. We have an aging population. We need to be a little bit more focused on having the comfort okay, and it's also that the current population, they have more economical resources, so they can afford investing in cooling options. And this is then just increasing the comfort demands. But on top of that, we are seeing this infrastructure developing in the south. Then, as we have heard quite well today, then there is a climate change, and this is quite a big change, actually. We can see it on the graph, where we have the current situation, or that is probably in 2000, so it's a little bit dated. And then we have projections for the 2011 to 2040, and we see the impact in the warmest month of the year. And then if you go further to the right of the graph, then in 2100, for example, we will see a very warm summer months. And this definitely will increase the cooling demands. And we have to handle that in some manner. And then also, we know from the previous speaker that buildings, we are building them as low-energy buildings, but they are maybe insulated so well that the cooling demands might increase. And then on top of that, if you are in a low-energy building, you don't spend much money on your heating bill or cooling bill, then you might just as well increase your comfort level, and then you use more energy. And when you have the buildings with tight insulation, with big windows, on top of the user preferences, you simply have higher risk of higher heating demands, overheating or whatever. So if we want to ensure that we have a long-term success when we are establishing new systems, then obviously we need to take into account the cooling demands. But that being said, cooling is and will be more and more important. Then we have to keep in mind that if you look on Europe, then it is a heating-dominated continent. And this we see on the graph, on the top graph, where we have heating degree days, and I have marked the arrow for Serbia, where we have approximately 2,000 heating degree days per year. And if you look on the cooling degree days in 2020, that is maybe 200. So it's fairly small if you just look on from a temperature point of view. So again, today it's a heating demand-driven continent. And if we switch a little bit forward and look into 2040, then it will not change. We will have more cooling demand for sure, but we will still have more heating degree days. And so again, it will be heating demand driven in the future. And this is then where it becomes so important that we establish the infrastructure that is able to cope with both heating and cooling demands, because we have a lot of research going on. For example, Heat Roadmap Europe, which has shown that there are actually more waste heat available than is needed to cover all building heating demands in Europe. And it would be really bad if we end up in the situation where we get rid of all our district heating system or don't develop such an infrastructure and go for individual solutions, because then all this waste heat is just lost and we are using extra energy for buildings. But today, our systems, they cannot handle, or they have trouble handling cooling demand in the existing systems. But before I go a little bit into the solution, then I want to focus a little bit on this area. And I pulled this graph out from Copernicus, a research platform in the EU, and it shows the development of degree days since 1850 until today, and then projections to 2100. From a historical point of view, we see that the demands are something, degree days, they are something like 2,300 on average, plus minus 300. But since 1980, it has been shifting downwards. So today it's more like on average 2,000. That's a huge drop in heating degree days and actually provides a lot of opportunities for the district heating systems. Because we could use this reduction in the heating demands to lower the temperatures. And by lowering the temperatures, we are more prepared to accommodate maybe future cooling demands. Because the cooling demands, now also on the graph, there it has been relatively low, but we are clearly seeing an increase in the demand. And if you can somehow couple together that we have the district heating systems running with a lower and lower temperature, then maybe we can make a business case out of cooling demands as well. I also want to show it in a little bit different perspective, where we have like the seasonal temperatures. Those are the historical temperature, and here we see the mean daily temperature over the year goes from 0 to maybe 23 degrees. And then we have some mean daily max and mean daily min temperature, which is of course a lot higher. But how does it then look in the, will it look in the future? And then we can switch the graph. Not a particularly big difference, it seems, but some slightly upwards. And if we then overlay the historical graphs, then we start to see something a little bit more interesting. There is obvious shift from the brown dotted line to the blue line being the future expectations. And this will have an impact. For example, if you look on the highest mean summer temperature, then what happened maybe 1 week before will extend over 2 months. So if you felt it was a little bit warm, the warmest day for the last few years, then extend that for 2 months. That might not be so interesting. But it's not only, if you look a little bit further and take it into the cities, then this is not the only aspect that is at play. because we also have urban heat island effects. And I just searched for what could be the case for Belgrade. And there is a relatively new paper that came out. It shows that you have up to 7 degrees heat island effect in the city. And that is just local heat island effects. Compared to the green areas, if you would compare it to outside of the city, it might be maybe 8 or 9 degrees. So that's a huge impact. And this impact will, of course, directly lead to a higher cooling demands. But the scenario I'm showing here, that is not a very optimistic scenario, but it's also not a pessimistic scenario. It's more what is likely to happen or was considered likely to happen in a few years. However, recently we have been hearing more and more that climate change is accelerating. So it might actually be that this is a little bit optimistic. So what would happen if we would focus our attention on like the 95% upper limit for this climate projection profile? Then we are moving to the dotted blue line. And this higher temperature of the year is not extending for 2 months, but 3 months. That's a huge difference. So we can think a little bit about that, how that would feel in the summer months in 20 years. Now, if you want to look on the cooling options in synergy with the district heating infrastructure, which you have here in Belgrade, then there are different options. It could be a dedicated district cooling system. It could be then with a co-generation of heating and cooling, so that we use the heat pump to provide cooling for the district cooling, and then heat for the district heating. This is a very well known and used, for example, in Stockholm and Helsinki, and works really well. And it is a good sector coupling opportunity. Another option could be to run the district cooling with a heat supply from the district heating. But that has the drawback that then we need to maintain the district heating system on a relatively high temperature at minimum 80 degrees or maybe 90 or 100 degrees. And having such a high temperature, that reduces the potentials for using alternative heat sources for the district heating system. So it's not necessarily so obvious unless we simply have a lot of excess high temperature heat. Another option to incorporate cooling within the existing infrastructure would be to go for co-generation at the building level. In that sense, it's more or less maybe the same as the district cooling, but just on a much, much smaller scale. You have a heat pump in the building, provides the cooling to the building, and then we dump the waste heat into the district heating system. Could be a really interesting solution, but it requires that we have low temperature district heating systems. So we need to develop things and take advantage of that. Our heating demands are being decreasing. If we still will run with a high temperature, then we could use absorption chillers at the building site. But as I mentioned with the district cooling and the absorption chillers, that requires the high temperature and maybe more carbon intense heat sources. Alternative could be absorption chillers, which don't need as high temperatures, but on the other hand, they have a very low cooling of the heat supply. So that might then lead to that we don't have any capacity in the district heating system to go that route. Now I will just go a little bit into the different solutions when it comes to the building, because one thing is to have the supply to the cooling or heating supply to operate the system in the building, but what can we do to distribute this cooling within the building? Then first of all, there are those typical factors that we need to keep in mind. Humidity, airspeed, air temperature, radiant temperature, the metabolic rate of the people that are occupying the building, and then the clothing. And that was mentioned by the previous speaker, that if we have low-energy buildings and we can spend some money, then we might also change our clothing habits, which can then drive the energy demand up. But what are the options that we have? We have possibility to have air cooling, and with the air cooling we can influence the air temperature and the humidity, but we might be limited by the airspeed due to draft and noise. And from my perspective, coming from Iceland, then noise in those units, that's annoying. Alternatively, it could be radiant cooling, where we influence the radiant temperature and the air temperature, but then we are limited by the humidity. But it's still quite a good solution, and especially where we have relatively low humidity and we only want to relieve cooling. We don't want full scale, just reduce the temperature by a few degrees. But if we have that kind of a solution, then we need to be absolutely sure that we are not having any condensation on your floors or walls where you have radiative cooling. Of course, the optimum would be then a combination of both, because then we can influence the most amount of parameters and get the best result. Independent on what we do, then we should think about doing it so that it supports the supply system. So if we have a district heating or district cooling, that means that we should try to have a cooling system that operates on as high temperatures as possible. Because the higher the temperature we can operate the system, the more efficient it becomes. This is what I had in mind to tell you, but then I look forward to see you in the next session.
Thank you. Thank you. Thank you very much. Zahvaljujem svima na pažnji i u ime našeg sponzora Delta Term, kompanije Delta Term, pozivam vas na koktel dobrodošlice u restoranu Zlatnik, a iza toga u 14 časova nastavljamo sa našim forumom, panelom, zelena tranzicija grejanja u Srbiji. Hvala lepo na pažnji i živjeli.